This is lesson 1-7, negative and zero exponents, and it starts in your workbook on page 48. This is example 1 on page 48 of your notebook. It says Marcella is playing a card matching game with some classmates. 4 matches, here they are, have been made. It is Marcella's turn, and she chooses 3 to the 0 power. What card would complete her match? So let's start by just organizing our data. So we have both exponential form and we have standard form, or what it equals. And we have 3 to the 4th. 3 times 3 times 3 times 3 is 81. That's this one. We have 3 to the 3rd power. 3 times 3 times 3 is 27. We have that one. We have 3 squared. 3 times 3 is 9. That one is done. And we have 3 to the 1st power, 3. And now Marcella has done 3 to the 0 power. So if I look at this, and I'm looking for a pattern, on the exponential side, I have the same base every time, 3, and the exponent is going down by 1, down by 1, down by 1. Well, that one exponent that's being decreased, that's a factor of 3. Because I started off with 3 times 3 times 3 times 3, 4 of them. And then I went down to 3 3s, and then I went down to 2 3s, and then I went down to 1 3. So it looks like I'm getting rid of a factor of 3 every time. Another way of saying that is I'm dividing by 3 every time. Well, 3 divided by 3 is 1. Marcella's match is a 1. Another way to think about this, let me put a squiggly line here. We could use the quotient of powers property. So I'm just going to make up a number. In the quotient of powers, I'm going to have the same base, and I'm going to have, in this case, the same exponents as well. So let me just take, 3 to the 5th power divided by 3 to the 5th power. So my numerator right here, I've got 1, 2, 3, 4, 5 of those. My divided by sign becomes a fraction bar. And 3, 2, 3, 4, 5 of those. If I start to cancel, 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 cancel. But if you remember, I have to have a placeholder, and it's not a 0. Anytime I take 3 divided by 3, it's actually 1. And usually 1 times whatever is itself. But if everything is canceled, it's going to be 1 on top and 1 on the bottom, which just equals 1. Which makes sense, because if I go back here, something divided by itself is 1. So the thing I want you to remember is that the 0 exponent property says that anything to the 0 power is 1, except you can't do 0 to the 0 power. That's undefined, and that will break the universe. But everything else to the 0 power equals 1. All right, I would like you to do the try it at the bottom of page 48. You can use a calculator should you feel that one is necessary. Go ahead and pause me, work these problems out, and then restart me when you're ready for checking. Shockingly enough, these all equal 1, because anything to the 0 power equals 1. except 0 to the 0 power, and that breaks the universe. The reason it's 1 is because every time you divide by one of those factors, eventually you'll get the factor divided by itself, just like we had 3 to the first power divided by 3, ended up to be 1. This is example 2 on the top of page 49. And we want to simplify the expression 4 to the third divided by 4 to the fifth. So that reminds me of the quotient of powers rule. So it looks like we have 4 to the third on top. We have 4 to the fifth on the bottom. They went ahead and they canceled. Cancel, 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 cancel. And they were left with 1 on the top and 2 4s on the bottom. And they said that equals 1 over 16. So it looks like if I had used the quotient of powers rule and kept my base and subtracted my exponents, it appears when I have a negative exponent, I will get a decimal or a fraction. What's actually going to happen is I'm going to take this 4 to the negative 2, and I'm going to give it a denominator. I'm going to flip it on its head. And when I flip it on its head, I'm going to ditch the negative. And I'm going to get my answer. These are the example 2 try. It's about halfway down the page on page 49. I'm going to show you how to do this one more time before you pause me and do a couple of these on your own. So I am going to put a denominator under here. Anything can have a denominator of 1. I'm going to flip it over. And the minute I flip it over, I'm going to ditch the negative, which equals 1 over 64. This is in simplified form, and this is evaluated. All right. What they would like you to do is write each expression in simplified form using a positive exponent, but I want you to go one step further and evaluate. So go ahead and do that. Pause me while you're working and come back when you're ready for checking. All right, let's look at this one. I'm going to put a 1 under it because I can put a 1 under any number. I'm going to flip it over, and the minute I flip it over, I'm going to ditch my negative. I have simplified this using positive exponents. To evaluate it, my 1 is not affected, but I have 2 times 2 is 4, times 2 is 8, times 2 is 16. All right, let's do one more of those. I can put a 1 under any number. When I flip it over, I change its location. I ditch the negative. This is in simplified form using a positive exponent. The 1 is not affected. And 3 to the 5th power, I've got to get my calculator. 3 to the 5th power is 243. So when you change the location, you are going to ditch your negative. So here are your steps. Use 1 for your denominator. Switch locations. If the exponent is in the numerator, put it in the denominator. If it's in the denominator, put it in the numerator. Just flip it over and ditch your negative on the exponent. This is example number 3 on page 49. I'm going to teach this to you just a little differently than what they have going on. So I have this expression and I want to write it with a positive exponent. So in our last slide, I said you can change the location. If the exponent's in the numerator, put it in the denominator. If it's in the denominator, put it in the numerator. So I'm going to change its location. I'm going to put it from the bottom to the top. I'm going to ditch my negative. Anytime you have a denominator of 1, you can ignore that. So I have 7 to the third power. I changed its location and I ditched the negative on the exponent. If I wanted you to go one step further, 7 to the third power is 343. This is simplified using a positive exponent. This is evaluated. This is the try it at the bottom of page 49. So I'm going to do one of these with you before I have you do one on your own. So when we have negative exponents, we are going to change the location. So right now the exponent is in the denominator. I'm going to move it to the numerator, ditch the negative on the exponent, and then I'm going to simplify this. If you have a 1 in the denominator, you can ignore it. This is simplified using positive exponents. If I wanted you to evaluate it, it would be 125. All right, you're going to pause me. Go ahead and do B on your own, and then come back for checking. All right, we are going to go ahead and change locations. The denominator has the exponent, so we're going to move it to the numerator. Ditch the negative on your exponent. If you have a 1 in your denominator, you can ignore it. This is now simplified using a positive exponent. And should I have asked you to evaluate it, it equals 64. All right, this is your key concept on page 50. When you have a 0 exponent property, it will always, always, always equal 1 unless it is 0 to the 0 power. That is undefined. It will break the universe. Don't do it. Other than that, anything to the 0 power is 1. The other property we talked about was negative exponent property, where we are going to end up with a fraction or a decimal. In order for that to work, we are going to change the location of the negative exponent. It's going to go from the numerator to the denominator, ditch your negative, and then simplify or evaluate as the question asks.